The ability to run async methods has been out for a little while, so I hope that you're familiar with it. If you're not, you're really going to like it if you do any sort of threaded or long winded operations and want to avoid your user interface locking up. Async can be and often is used in conjunction with await, and it's used for long running tasks that, if you ran synchronously on the UI thread, would block the user interface and basically give the impression that the application was locked up or frozen. And that gets users frustrated, and they shut things down and reboot and do all sorts of bad things in the middle of your long winded operation. Async actually uses a different thread than the main UI. Now, of course, we can use multi-threaded and have been able to use multi-threaded programming for ages, but it's a little bit of a pain to construct. Async simplifies that tremendously. So we can use async with await, and our UI can remain responsive, but our structure is actually still very much like a synchronous method, and we don't have to do a lot of eventing and callback and all that kind of stuff. So it's really easy to implement. So taking a look at the old thread method, and this was about as simple as it gets in order to be able to fit it on a slide. So I have a method called start process, and it's going to start some really long-winded thing. So I create my thread object, and I create a new thread and give it a new thread start with a worker method. And then I call on that thread the start method, and that will run the worker method in a different thread. After I call thread start, this method will immediately return back to the main UI. So my main UI is responsive, and my worker method is working on a secondary thread. That's great. That's exactly what I want. But here's where it gets more complicated. You'll note that my worker method has no parameters, and it has no return type. It also doesn't have any obvious way to go get back to the main UI thread. So I have to fire an event or call a control invoke or something crazy like that makes my code a little bit awkward. I can use parameters, but I have to format them in such that they end up in delegates. I can't just do anything I want. And obviously the return value, well, it doesn't go anywhere, so that doesn't help me at all. So I don't have a return value that I can work with. So there are limitations, and of course there's always ways to get around this, but they're awkward, and they require a fair amount of code that just makes it more difficult to support and a little bit less readable. So let's take a look at a real async method. And this async method will call out to a website and get a response and return the string response. So I have the async keyword up front, and then I have the task keyword with the type string. And that's going to be my return type that I'm going to return a string. And I can pass in whatever parameters I want. So I have the string URL, I create a web request out of that URL, and then I await the response for that request. So I call request.getResponseAsync, which is another asynchronous method, and I use that keyword await. So despite the fact that getResponse is an asynchronous method, if I use the keyword await, it will wait for that to return. If I didn't use the keyword await, it would return immediately, and I would just basically be starting to get that response. By using the keyword await, I avoid some kind of polling loop or callback mechanism in order to get the response. So in that way, it acts like a synchronous method, but because I'm using await, it doesn't block the thread which it's called on. So I get the response to the request, and I run it through a stream and ultimately return the string of that response. So that's what the async method looks like, and here's what it looks like when I call it. I simply have, again, an asynchronous method, get string from web, and string response is equal to, again, await, get web response, and passing in some sort of URL. And I can get that as a string object, and I can directly access the UI. If I was using the old-fashioned thread way of doing it, even if I had a callback from the thread or an event delegate from the thread, I would have to be able to get back to the user interface thread from that secondary thread. So I'd have to do something like a control invoke on a Windows form application. So it just makes it more difficult to access the UI thread from a secondary thread. Async takes that away, and I don't have that complication anymore. I can directly access the UI with this string response. So that's really simple. The async methods and the task class also supply some other nice little methods. So in this method, we're going to run two tasks asynchronously, and we're basically going to run them simultaneously And we'd like to wait until both of them are done before we return out of this method. So we create a tasks array and create our two tasks using the appropriate methods that we want to call for those two tasks. In this case, download file 1 and 2. And then we call await task.whenAll and pass in the tasks array. And that will start both of those tasks running, and this will not return until both of them are finished. So if you have, for instance, like this, a multi-file download, and you don't want to return to the user until all of the files are downloaded, this works perfectly for that kind of idea. We can also do a similar thing, but we can get the first one. So if we have two tasks that we essentially want to run in the rough equivalent of a race, we can again create our task array with our two download file tasks, and then use await task.whenAnyTasks. And that will return when the first task gets done. It doesn't matter which task it is, whether it be download file 1 or download file 2. When either one of those gets done, the await task.whenAny will return at that point. The second task will keep on running, but will return from the method when we get the first download. So again, another little variation that can be handy. So that gives you a good idea of what async can do. And there are a number of other methods associated with the task class as well. And you can get to be more complex if you wish. But I think one of the great things that really can be used for async is to attach to remote servers and get responses, whether it be URLs or download files or upload files, because those are the kinds of methods and tasks that take time, and if they're done improperly, can freeze UIs and frustrate users. And they work perfectly with using the async keyword. So do take a deeper look at that as well.